Go. Okay, so this is our project for Comp 429. How we did this was we did our solution in Python. We're gonna start on line number 321, where we initialize our server. We initialize our server through a file path, and also we specify an interval through the command line arguments. Now scroll all the way up. All the way to the top. So as you can see, we did this in a class organization method. We use the init or the constructor to go ahead and initialize all of our variables, and we all unpack them and read them through the self.readconfig method. So go ahead and scroll to the reconfig. So the purpose of the reconfig is very simple. All it's going to do is just read the information from the topology file and just build the routing table. And it's going to build the other information, like how many other neighbors there are, the lookup table for the IP imports. It's going to go ahead and set all of that information there, and also read the different costs from its neighbors. Go back to the top. So here we go. So this part, all it's doing is essentially when the server and the server side is running. It is going ahead and running a loop that's just taking in input arguments concurrently if the user decides to do anything here. So essentially how we did this was we did this in a client and server using threading. So we basically implemented client and server on two separate threads. So that's the way that we were able to pull off peer-to-peer. Using this method, if you scroll down to the bottom, so send tables. The purpose of this function, essentially what's happening, why I brought this here, was because this is on the client thread. The client thread is performing this function in a self interval. So let's say interval is 10 for server 1. Well, server 1 is going to wait every 10 seconds, and after 10 seconds have passed, it's going to run this function right here. Not the client, but it's going to run the client, and then it's going to run the send tables, which essentially client, all it does is it just packages its information into a pickle object. I think it's byte stream, and then it's able to pull that information and send it through the socket. That way, when the server side of the program reads, let's say this is server 2 that it's sending to, once it receives that information, it unpacks it using the pickle. And that happens in the handle client method. So scroll. Handle client, right there. So basically the pickle loads. That's when it goes ahead and handles it. If there's any update, when the updates happen, updates will happen here as well. So if it gets the update flag, then the update flag will send the new tuple or the new value and set it so that all of them can be updated the moment that it gets sent. So essentially it's like a fire truck running through the street. It's basically like it's a signal saying, telling everyone to wait, for example. This is essentially what's happening. We're using kind of a semaphore sort of kind of pattern here. So as you can see, the received dictionary and then also the server and the updated table, that's essentially all this information is getting unloaded every single time every interval gets sent. Also, the step will also run it'll also run the send tables as well. So essentially, like if I map it out clearly, we have two threads happening. We have a server thread and we have a client thread. The server thread is accepting information or accepting tables that other socket or other servers are sending. So let's say there is two nodes in our network, server 1 and server 2. When server 1 sends the information or sends its table, server 2 will be receiving it on the server side. But on the client side is essentially where you're actually sending the data, right? So that's essentially what we're working with here. That's how we're doing it. And then Sergio, can you scroll up? So when the server goes ahead and handles the client, it's going to call receive table, which is important. Basically, we have two tables happening here. We have the table that has been inputted through the parameter, which is basically the foreign table, and the self.routing table is the actual table of the server. So we're checking to see if there's any new values that we don't have. If not, just go ahead and populate them with what we need. And then also we call the refactor table. So that's important. So the refactor table, scroll. Essentially, this is exactly like our homework. This is just running the distance vector algorithm. For example, I'm pulling out the source and destination, and I'm basically just running each of my values, and I'm checking if there's any faster way I can get to the different nodes in the network. Hence, using the for loop, checking the different neighbors and checking the distance between the neighbor and then their distance from them to the result. And we're checking and we're taking the minimum at the bottom, and we're using this new cost list to essentially look at all of the values from each of them, and then we find the minimum of that one. And if the minimum is less than the current one that we have, then update it with the minimum. Essentially, what's happening. Everything else in terms of our functionality is just helper functions if we need it for any other particular functions. But essentially, that is the core of our system. We have pretty print, which essentially just prints out the routing table as well, which is very important. So I think we can go into demo. So essentially, how we did our implementation was we used Python dictionary to be able to hold and store the values within our basically in our routing table. So essentially, the first column is the source and the second column is the destination. So very similar to the topology that we were given, we are essentially storing all our values in this case. So essentially, our key is just a tuple with the source and the destination, and then the cost is going to be the value of that key. Hopefully that makes sense.
Why right here, that is how we're displaying it. So from that tuple, we're going to display the first one, which is going to be
Node 1.
Yeah, node 1, and then this one is going to be node 2, and then
Yep.
the value that's at that tuple is going to be the cost.
Yep, exactly, yeah. So that's the cost. So as you can see, this one's fully populated. Node 2, Node 3, Node 4 sent all of their information to Node 1. And receive method also updated it and populated the values. Assuming that the value doesn't exist in there, if it has the neighbors and they haven't sent the information yet, then we assume it to be infinity. So that's very important to note as well. We assume it to be infinity. So that is important to note down.
Yeah, and so now this is also the other this is node 2, which is displaying its table. It's different than node 1 because the connections are different than this one, and then just to display that the others are showing theirs also.
So you saw how 1, 2, the cost from 1 to 2 is 7? Originally?
Yeah.
It is because of the distance vector algorithm. It found a shorter path, and the shorter path is actually to node 3, and then node 3 to node 2, which because 1 to 3 is 4, and then 3 to 2 is 2. So that's how I was able to find a faster path. So that's just quickly noted that the distance vector algorithm is working properly.
So now we're going to show how we could do the update command. So
yes.
You could just type update, and then we're going to change the node 1 to 2, and we'll change that to weight 1. And now if we display that, you will see that that gets changed, and then also the opposite direction gets changed too. So going from 2 to 1. And now you could see that this node 2 is also going to get that updated value.
So yeah, so you can see its neighbors also got that information as well. So that's important to note for the future, is that in terms of when they're doing more distance vector algorithm calculations, you could see that we've properly sent the information showing that the update has been addressed for all of the tables, in all of the nodes in the network.
Yes, which we should probably also show that to here from 1 to 2, that's getting the value of 1, and then also going from 2 to 1, that is a value 1.
Yep, and that was the updated one because the one. Yep, that's perfect. Step, just go ahead and do it. Basically, all what step does is it's just forwarding the packet or the table. And then also type in packets. Oh, 534 packets. Wow. Okay, now try it again. Yeah, so it's sending a lot. It's sending a lot of packets
Sorry,
very
yeah,
quickly.
yeah.
So yes, that sounds right.
That's
Yep.
happening because the amount of time is 2
Yep.
seconds. So for
Yeah, and for all of the
seconds,
nodes.
yeah,
Yeah.
yeah.
The amount of times this receives. Yeah, that's a lot. So that's good. And then also now I think the last one to do is just disable and crash.
Now here we're going to show that if we disable from 2, we're going to not receive data coming from this node. And now if here I try to update from 2 to 1 as 1, that's going to get updated, and this one will not receive that data, which is exactly what we want. Yeah, now we're going to crash this one, and now if I display that data, you could see that it's now updating with the correct values, and every single other node should receive inf for the ones that are
Which it
related to
does.
the one
Yeah.
that crashed.
So just to keep in mind, the inf it's still showing on record that the node is like it's still gonna have that information on file, but it's essentially it's still crashed. Like it's for sure not gonna find a way to get to that node. So it's yeah, in that sense.
Yeah.